the greatest pleasure, and if you don't mind, we get straight into it, to introduce one of our talented postdoctoral researchers, or research fellow, Edgar. Edgar has been with us since quite a while, and Edgar came with very strong credentials even before he joined us, working for 15 years, I think, at the interface of research and practice. And you've done tremendous work, contributed to outstanding papers that were highly visible, worked with CSIRO, UQ in that space. With Tim Castell, you had one of the leading researchers in the innovation space here in Queensland, being your principal supervisor. So you came well trained to us. Right now, you are a rare breed because you spend 50% of your time at UQ and 50% time with us. And we really try to create it as a perfect boundary spanner between those two research hubs. So we are delighted to have you here. Before I introduce your topic again, and in the tradition of QT, of course, I'd like to acknowledge traditional owners of the multiple lands we all stand now collectively, and of course, pay my respect to the elders, past, present, and emerging. Edgar will talk about what he calls innovation science, and maybe that's also in the tradition of the Center for Future Enterprise, give birth to new concepts and see if we can create a first mover advantage by seeing mega trends, opportunities before anybody else. So Edgar will maybe spend the next 30 minutes or so, maybe 25 minutes, to elaborate on his thoughts. There's a paper behind this. And also I'd like to acknowledge Kevin's tremendous contributions to the paper and the state that it is. If at any point in time, the teaser that you will get in the next 25 minutes motivates you to see more, contact Edgar, and we will share, of course, the paper. But for now, Edgar, if you don't mind, I would hand over to you so you can share your slides. Take us on a journey on what is innovation science, what's innovation scientist. Then, of course, we've got plenty of time for a bit of Q&A. So please welcome Edgar on our virtual stage. Thank you so much.
Great, Michael. Thanks very much for that very nice introduction. Just going to share my screen here. Great. Thanks again, Michael. And thanks, everybody, for zooming in today. I hope you're nice and safe and healthy at home. We're going to get through it. So today I'm going to share with you a work in progress. So this is an idea that I've been developing with Michael Roseman and Kevin D'Souza, as he said. But before we jump into the actual presentation of the innovation science, I thought it would be a good idea to share with you where my research is at the moment, so you can actually see where all this is actually coming from, where all these ideas are coming from. Yeah, so in my research of innovation management, I'm currently looking at the intersection between innovation and technology, the cognitive technologies is how I call it. So, which includes, AI, machine learning, and big data methods. So, what part of my research involves the actual use of those tools, those technologies, to create novel innovation measures for innovation activity at the macro level. Some other part of my work involve understanding the relationship between, or how these technologies are being used by companies and their innovation performance, whether there's a relationship there, how and why. But I'm also looking at things more holistically and try to understand from a higher level perspective how this, evidence-based, knowledge-driven approach that characterizes technologies can be used, can be harnessed to create better management of innovation processes and projects. So in this level, this is where the innovation science idea is actually coming from. Great. So let's talk about innovation science. So when we think about innovation over the last 10 years, there have been some warnings that there might be something going on with the innovation systems globally. Okay, so in this chart here, this is by Nicholas Bloom. This is from a paper he titled it, "The ideas are getting harder to find." And that pretty much says it all. So in this chart, he plot research productivity over time, which is decreasing, and the amount of resources, in this case, number of researchers, increasing over time. So we can see that decreasing productivity trend. And it's a trend that is is actually reflected in many other indicators. For instance, R&D expenditures by industry, overall by country, patents, publications, and innovation investments. So there seems to be something happening, and there's a higher degree of complexity in the innovation process, the innovation management. But you can say, well, that's fine. I mean, at that high level perspective, we're interested actually in what's happening at the firm level, so this doesn't affect the firms. Well, there's evidence that is contrary to that. There's evidence suggesting that this problem is now permeating into the firm level. And you see these numbers here. As you can see here, the managers are not necessarily happy with the innovation investments, most of them at least. They're not satisfied with the innovation performance. They don't feel ready to effectively capitalize on the innovation activities. And then when we think about the potential solutions to that problem that we're seeing at the corporate level, we see that many corporate innovation programs are actually strongly emphasizing creativity, empathy, and out-of-the-box thinking. So this works great, but also this is a double-edged sword, because creativity without discipline, it can be messy. And if we think about the previous slide about the complexity and the difficulties in innovation, you might as well ask, is this the right approach? Is full creativity is actually the right approach? And when you look at successful innovators, you see that creativity is just one side of the coin, just one thing. There are actually many examples of companies that have officially went bankrupt because they paid too much attention to what the customers were saying. This is saying by the CEOs of those companies. And one of those companies is Birds of Prey, based in Australia. They say that they were paying attention to what the customers were saying rather than what the customers were doing, and try to find different knowledge sources that tells them or enrich the story of what's happening there. And more importantly, they weren't connecting what they were learning from the customer side and with the knowledge that they already have as an organization in terms of operating in a particular industry or knowing the customer base on the past products, on future products. So there's no connection with that knowledge base that they already had. And so you can say that this creativity process was somehow misguided. So we can say that, low innovation productivity and a biased creativity as part of the innovation process is creating an environment of uncertainty and unpredictability, which makes it really hard for companies to effectively innovate, right? So this leads to the question of what approach can established firms adopt to make innovation more knowledge-driven and reduce that uncertainty? And also, how can we apply this approach to a variety of real-world innovation models? So we had to come up with something that actually works in a number of cases. So we argue that an approach based on the scientific method is a powerful solution. And because of the nature of science, that allows us to use that approach in a number of different innovation models. And I'll talk about innovation models later on. Okay. So why science? Well, the quickest explanation is that it's the best approach humans have to deal with uncertainty, right? So if we go to a textbook definition of science, it says that it's the pursuit of knowledge that allows us to understand the world, and it follows a rigorous methodology based on evidence. And the application of the scientific approach in business is nothing new, really. So Frederick Taylor, which was a mechanical engineer who later ended up working with Ford, he found a way to use scientific principles to reduce the uncertainty in the manufacturing process, particularly in cars. So he did this in 1911, and it was very effective. It was a very powerful idea. So no wonder Ford hired him as a consultant later on. So since then, we've been sort of sanctifying different innovation business functions within the organization. So we have, for instance, operations science, we have management science, and more recently, we have data science for decision making. we argue that innovation is next in line here. And why is that? Why do we think that? Well, there are very relevant cases actually today that shows that integration between or that complementarities between scientific rigor, the scientific discipline in one hand, and innovation in the other, innovation effectiveness. And when we think about innovation effectiveness, what are the actual companies that comes in mind is Pfizer at the moment. So 1 month ago, the CEO of Pfizer published a HBR piece detailing the process of the production of the COVID vaccine. And it's a very nice story. It's very interesting. You can actually see how a strong commitment to science was core to the development of this novel product in the most effective way in the quickest time possible. So it's a nice story there. Right. So going back to their actual research, the first step that we followed was to conduct a systematic literature review on science, the philosophy of science, the use of science in a number of different scientific disciplines. And we identify different particular characteristics that define what is science, right? Different dimensions of science. So we use this as features that guided our data collection and analysis later on. So what we learned so far is that innovation is characterized by very specific goals when it comes to knowledge. It's knowledge production, the main objective of science, the production, dissemination, and application of knowledge. Is that search of the discovery of truth. So it goes at the core of what science is. Science also adhere, respect norms and principles. So everything you do in science has to be valid, has to be reliable, and has to be reproducible. So norms on this side. It's also characterized by a particular process, systematic process. And having a systematic process is what reduce subjectivity and add objectivity and reduce bias. So when I say process, is any combination of asking questions, hypothesize, test, or experiment, and then conclude in the based on the data. And then lastly, there are different ways of reasoning in which you can conduct inquiry in science. So you can deduct, induct, or abduct, and these work as different angles to explore the particular phenomenon in a more comprehensive way. So these are the 4 features that actually helped us throughout the process. And there is a theoretical support for these features, and we found this support in the knowledge-based view and innovation. We're tying these ideas with the concept of organizational learning and in absorptive capacity. Great. So it's really, we think about, okay, innovation science, it's really easy to see how that can be applied to a company like Pfizer, right? On typical science-driven, R&D-driven company. But what about the rest? What about the rest of the companies that are actually doing non-R&D? So in order to explore the applicability of innovation science in a more broadly, we needed a framework. So we developed this framework with different innovations and different innovation models that we see in practice today. So we use 2 dimensions. The first one is the within the firm, beyond the firm, it's the firm boundaries, dimensions, and the other one is the innovation driver, the technology push over market pull. So we have here R&D driven innovation, the typical, your typical Pfizer company. We have design driven innovations, or companies that start from recognizing or understanding the problem from the market side and build from there to innovate. Open innovation could be market pull, it could be technology push. So, but it's definitely beyond the firm. That's obvious. Open innovation is about using the external resources, capabilities, and knowledge to innovate. And then we have Affordance-driven innovation on the other end. This involves companies that are pushed by from a technology perspective. They develop technologies, and at some point in the development process, they open up the technology, offer it to users, and learn how users interact with their technology to continue the development process. So these companies typically use prototyping and simulation of products in a digital environment. Great. So we wanted to identify successful innovators in each of these innovation models. So we went across a number of innovation rankings, and we identified 4 companies, the following 4 companies. So we have Nike for design-driven innovation, we have Roche for R&D, Samsung for open innovation, and Toyota for Affordance driven innovation. So it's important to understand that these companies actually do innovation models or conduct innovation models different from the main one, right? So in the perfect case here is Samsung. Samsung is pretty much all over the table here. They do any of these models, but they are recognized to be at the forefront of this particular innovation model, the innovation model that is on the top of these images here. Although they do other models, they're very good at doing this. We then use secondary data. We collected data from these companies through a number of sources, which includes company websites, news, press release, reports, and past case studies. All right, so what have we found so far? And recalling this is a work in progress at the moment. And don't worry, I'm not going to go through this table in full. It's just to show that we found significant evidence for each of the companies, for each of the innovation features. We sort of used the initial data, the data that we collected, to refine the innovation science features. If you remember the first slide about the features, those were our characteristics of science, but we wanted to ground that into the innovation context. What does it mean to have those 4 features when we're talking about innovation? And the data helped us reframe and refine that. So this is what we did exactly in this findings number 2 so far in terms of the features. So we learned different things of each of the 4 features, again, related to innovation. We learned that the 4 companies share a company-wide commitment to knowledge production. So they generate, they share the learnings, share the knowledge across the organization, and they use this as a sort of like a bank account where they draw ideas from that to keep the innovation engine going. For the scientific principles feature, we learned that all these 4 companies, they have multidisciplinary teams that are in charge of generating and developing the novel ideas, which ends up in products, processes, and business models. And then they use, which the interesting thing is that they use scientific principles as a glue to hold these multidisciplinary teams together, right? So they use it as to normalize these activities and to make sense and make order of these activities conducted by multidisciplinary teams. In terms of the systematic method, all of them share at least one systematic method that is in the core of the innovation process, that they rely on this method to innovate, right? And not only that, the systematic method is actually shared, distributed, and easy to access across the organization. They even promote this method. And one example of this is something that Toyota has, which is called the A3 report, which is a guidance to create solutions to problems, which is a reflection on the scientific method. They promote the use to the point that today, the report is being used for, from people in R&D departments to people from finance. And we have, in terms of reasonings, we found evidence that these companies use the 3 forms of reasonings depending on the context of the research or the question that they are actually exploring. Although they share they use the 3, there is one reasoning that typically dominates, and we talk about this now. Right, so the last finding was about the features of innovation, of innovation science. But we also wanted to understand what are the nuances of this innovation science when you see it across innovation models. There's got to be some differences. And we found a number of differences, but this is the more important one. So in terms of the knowledge-driven goals, we can actually see that the innovation models that depend on resources beyond the firm, the open and Affordance driven, For them, the knowledge generation and the integration is about integrating internal and external knowledge effectively. Whereas in the other two, it's more about connecting knowledge from different brains within the organization. And we see here the case of Nike, how important it is for them to connect scientists, your group of scientists with designers. So other differences that we found in terms of scientific principles, they use the scientific principles to normalize different processes that reflects the innovation models. For instance, for Roche, they use it to make sense, or to sort of make sure that they follow the rigor in terms of the multiple R&D efforts that they're doing. They sometimes have different R&D teams working on the same idea, right, which works as a reliability. So they use the scientific principles to normalize all that activity. And you see, for instance, that for Nike and design-driven is about bringing rigor to that understanding for that acknowledgement of user experience. For the systematic method, we identified that there are differences in terms of where the systematic method is being used across the innovation life cycle, the innovation process in the organization. Roche, the R&D-driven company, they tend to use the systematic method both at the discovery and at development stage. So the output of one is the input of the other. Whereas the other three companies tend to use these methods in the early stages, the discovery stages of the innovation process. And we obviously, we found differences in terms of the dominant reasoning that these companies rely on, deduction for R&D-driven and abduction for design-driven. There's no surprises there. And some form of variation of deductive and adductive or inductive, a combination of both for the other two models. Great, so what have we learned so far? So, and also, what are the implications of an idea such as innovation science? How these connect with the actual problem that we see in the third slide? Well, from the case study so far and from the contextual case of Pfizer, we can actually see how these companies are building. What they're building is a body of knowledge, a systematic body of knowledge that is connected together, provide evidence, it has insights, and then they use this as a framework to guide the innovation decisions. And when you have something like that, like a support to guide your decision, that's what decreases uncertainty. So these companies, for instance, they use that knowledge to prioritize different innovation projects, for instance, to kill some innovation projects, to seed some other innovation projects. They even use it to sort of anticipate certain, potential return on innovation investments for some companies. So they can actually, for some projects, so they can actually prioritize their efforts. And we believe that the mechanism to reduce uncertainty has important implications for companies, because it makes the innovation function more approachable and accessible for companies, especially for companies that for which there's still some sort of behavior to a short-term sort of behavior and some risk aversion, which are a lot. It's a lot of companies in that bus. So again, we think that an idea like this have important implications for practice. Right. So we already submitted a HBR article, a pitch. We're still waiting for the response for that. We are about to complete a full paper with all the information and all that I shared with you today. We will like to conduct a parallel study, a twin study, this time with quantitative data, with a larger sample to sort of assess the relationship between this innovation science approach and some sort of innovation performance frame measurement. And this is more aspirational, but we would like to design programs to support innovation science at the corporate level. This is something that probably not in the short term, but it's something that we're definitely thinking about to do in the future. And that's it. That's my last slide. So I would like to sort of turn the tables here and ask you questions. I will really love to see any comments in regards to future research ideas, how these innovation science idea can connect with other initiatives within QUT, but also what could be the implications in terms of theory and theory development in innovation. For instance, we're thinking about disruptive innovation theory. We're talking about reducing uncertainty. Does that mean that companies will be able to create more radical innovations? What does that mean for the disruptive innovation theory? That's just one example. You can ask questions and make comments now, or my email is here, and please keep in touch. Thank you.
Thank you so much. Edgar, was a great summary. That's a complex topic. You did extremely well and bring it to the point. And I like to see, I like your ambition going straight to HBR, and it'll be interesting to learn from the feedback you get to your pitch. Like usually, there's a great turnout here. So I appreciate anyone, any comments, questions, or answers to Edgar's questions to step up. Please raise your arm, unlock audio and video, and the stage is all yours. Anyone?
Michael, it's Wendy.
Yes, go for it, Wendy.
So Edgar, I was a little late, so forgive me for that. Thoroughly enjoyed your presentation. So you've drawn your cases from individual companies, which is great. Could you apply this at a sector level or an industry sector, a subsector level? Would that be your next kind of step, to be able to look at what sectors are actually doing differently and how how one sector might learn from another? And I'm particularly interested in things like the government sector and innovation as a space for fertile work, perhaps.
That's great. Thanks very much for that point, Wendy. That's a tremendous point. It actually goes at the core of my second bullet point, the next steps. That's exactly what we want to do. It's tricky because we have a lot of options and we have very little options at the same time when it comes to measuring this approach, right? One of the things we're thinking about is measuring the scientific capability, scientific capacity, or particular at a country level, which is typically done in the typical papers of research policy, for instance. And we can do this at the industry level. So you can measure it by number of R&D personnel, number of scientists, whether the company has a scientist in the head, the CEO. So somehow, that's the idea we have so far, somehow measure the scientific capability and find an innovation measured at that level and try to assess the relationship from there. That's just one idea, but it's a great point. That's the direction we want to move as well.
Thanks, you,
Edgar, and thanks, Wendy, for a great question. Then maybe over to Judy and then Irvin, please.
Sure. So, hey, Edgar, nice work. Hi. I like, it's well known there are different models of innovation in different areas of science. For example, whether you're looking at a biological place, whether you're looking at IT, software development. So it's nice that you've actually developed a bit of a framework to map those. I guess the other notion around innovation is it's really, well, it's about novelty. It's actually about delivering new value. So if you can actually incorporate new value into your model, I think it would be stronger. But I've got a question about the design-driven innovation and the affordance-driven innovation. And even looking at your tables, I think you mentioned users in design-driven and customers in affordance. Often, of course, they're much the same thing. So and of course, abductive is really essential in both. So just wanting to make sure you sharpen that, given you're using that in your framework, and maybe it's around different value. Because of course, suppliers are just as important in design-driven innovation as they are in affordance-driven innovation, because often that's where the information is, like how the design of whether it's a product or a service needs to be reshaped. So that would be something that I think I'd probably just ask you to sharpen that a little.
Yeah, that's a great point, Judy. Just making note of that and the value sort of level there, and yeah. So you actually touching the point of customers and interaction with customers, not only to co-create but to actually create a long-term relationship there, which is part of the value creation, right? And it's interesting, and yeah, I guess we can actually reframe that in terms of, instead of users using customers for affordance driven. The idea and the examples that I was having in the moment is actually probably not the best example, but it's a good illustration. I don't know if you were aware of the Google Glasses. So Google Glasses is a technology that Google developed. It's a virtual reality, immersive reality technology. And at the beginning, they didn't even know what to do with it. So it was completely pushed by technology. And then what they did was to share it with, I believe, based on the information that I've got, users. They were not actually customers. They were actually advertising, in a particular sample, saying, who wants to use this? And companies raise their hands and say, oh, I'm going to give it a try. And then they look at the reaction with the technology. Unfortunately, it wasn't as successful as other technologies, but that was the sort of thinking that it was in my head when I started to talk about users. So, but yeah, it's a great point. It's actually a good point.
It was a good point, I think, in terms of just being very sharp with your terminology. So point well taken. Thank you, Judy. And then over to Irvin, and then Artemis, please, and then John. Irvin.
Thanks for your enlightening presentation, Edgar. Just a bit of a small question. To my best understanding, a lot of the, let's say, more traditional innovation approaches, in particular like systematic innovation processes, actually have the origin in engineering. Like they're very similar to the new product development process, NPD. So what is new or different about your scientific approach and the more traditional engineering approach that people had to innovation? And also the second question is, as we move, this seems to be a very industrial approach, and as we are in a post-industrial society, is this approach still the most suitable one for innovation?
Yeah, that's a very good question. And I guess that there are different ways to sort of answer that, but I guess this point is debatable, of course, but you can say that engineering perspective of systematic processes is more typical in technology push sort of R&D companies, right? And we thought that there are a lot of frameworks that just work in one model. So we wanted to sort of expand whatever we're offering to cover the different elements. And that's the reason why we thought, okay, science provides you, the nature of science is agnostic in terms of what type of if you're working with engineers or working with designers, it's just about knowledge generation and production, which is the common goal. But I guess that that's a valid point. And I think that the main difference with that is exactly that. Is we wanted to sort of expand this idea, provide some guidance or clarity with the different innovation models. So yeah, I guess in expanding that point, and I'm looking at the clock now to see if I can you can actually say the same thing. I'm sure you know this. You can say the same thing with a Lean Launchpad and Lean Startup methodology. So the Lean Startup methodology is not about engineering, but it's about the same point. Lean Startup is about, they call it as an experimentation, guided experimentation, and so on. But again, if you think about that, if you think about Lean Startup, it only works at the project level. So you apply Lean Startup with a particular project, and you develop a product, and that's it. So there's no leading for the large corporations, at least. At the startup companies works differently, because one project, one company. That's it. You learn one project, you learn for the entire production of your value. But for an established company, you can say, well, you already have Lean Startup, but it doesn't apply to a number of projects. How do you connect with those projects? And again, that's the point we wanted to make with innovation science, making it, which is risky, I recognize, but to make it applicable across different innovation models. I don't know if it answered your question, but it's a great point, actually.
And I understand, Irvin, your work is also quite influential. So it might be good for the two of you to have a bit of an offline conversation. Over to you, Artemis. I understand you had a question as well.
Yes, thank you very much for that. I really enjoyed the presentation. This connects well with what we're doing in other spaces, of course. Yeah. My question in the chat line was about tensions. Did you have conversation in your analysis? Did you find tensions experienced by these firms when they're trying to implement this model that you're recommending?
Yeah, that's a great point. And the case that I have in my head is actually, to some extent, Nike. when they wanted to join brains or connect brains from scientists and designers. They think differently. So there are a nice couple of articles about resolving that tension between different mindsets, right? I guess that at this point, that insight escaped what we were looking for. But I guess that now, you know, thinking about your comment, maybe it wouldn't be, maybe it's a nice, good idea to just go back and see if that plays a role with the way they're conducting innovation.
I don't necessarily think that needs to be in this piece. And I want to clarify that maybe to help you thinking about your paper as well, because I think that you almost have two focus. You've got the innovation science framework, which I quite enjoyed. But then you've got the 4 alternative models of innovation. So it wasn't clear to me, are you suggesting that the innovation science approach applies to all 4 models, or they're more relevant to a particular type of model?
Yeah, the idea is that it applies to all models. It's something that if you look at a designer company, there's some traces of innovation science. As you look at an open collaborative sort of environment in an organization, there is evidence of scientific approach. So yeah, that's the idea.
And did you find it applied differently to the 4 models?
Yeah, well, at this point, we're still in the analysis, but at this point, we found that, I think one of the last slides, finding number 2, I have some differences there, and I can share it with you later on. In terms of the scientific method, so they have the innovation process, but they use a scientific systematic method at different levels of the innovation process. So Roche used that pretty much all of the board actually. They use it at the early and at the development very rigorously. The other companies tend to use it at the discovery phase. So there's a bit of a difference there where they use these sort of scientific rigorous approaches, right?
So I think that nuances is more interesting to help us apply the framework. Yeah. Thank you.
Yeah, that's good. Thanks very much for that comment. Taking note of that, actually.
Great comments. I mean, we've got different types of science, theory-guided science, empirical science, design science, and you probably have different facets of innovation science. Over to you, John, and your interest in the impact of the size of the organization. And if John,
sorry about that. I haven't got my video on. I'm sorry about that. Yeah, Edgar, I was just wondering if you've looked at different sized organisations, because smaller organisations don't have the bankroll to necessarily, and need to be very effective with their money. So, yeah, if you've applied it to smaller organisations, because a lot of R&D happens in smaller organisations, doesn't it?
Yeah, that's a great point. That's I think one of the missing slides were actually the limitations of the research. It's actually one limitation. We because it's a new framework, it's a new approach, it's a new model. The focus was on expanding the data available. So that's the reason we went to these major, well-known companies to expand this new, potentially new phenomenon that is called innovation science. But in saying that, the implications for the rest of the economy and rest of organizations, yeah, it's something that it's a limitation at the moment. And I guess you're right. So the size of the company, they all have more than 100,000 employees, billions of revenue every year. What happens with the other side of the economy with small companies? Yeah, it's something that we will love to explore. Maybe in the second step, the second phase of this work. But it's a good point, though.
Yeah, I mean, the question is if innovation science is more expensive than innovation, if using a scientific approach really means the cost to innovate go up, or will it ultimately go down? And the question is, can I scale down innovation science? Is something we need to discuss carefully. Judy, please.
Okay, so Edgar, I've got a couple more questions.
Yep.
So I guess I'm wondering, have you looked at different models of knowledge generation, knowledge inclusion, and knowledge integration in each of those 4 areas? That's the first question. Second question is, and maybe it's just what you presented here, sort of as ideal types, but really it's very much around products. Whereas now we know companies are moving into services and systems of services. In fact, product service system is really where most companies are going with their innovation. Have you thought of looking at services in a similar sort of way using your framework?
Yeah, that's a very good question. So in terms of the knowledge models, we haven't thought about the differentiation of the knowledge production sort of mechanisms at the moment. I guess that is something that we're going to incorporate, bearing in mind that we don't want to clutter the model too much. We already have 4 models, 4 features. So yeah, so it's something that we had to figure out how to include it. It's a good point. And in terms of the products and services, yeah, I think that, and I guess that most of the data actually reflects, I would say, mostly what they've done to generate products and technologies. I guess you're right. So that's a good question. What happens with services? Is this applicable to services? We have to dig that out, but I'm sure that there are ways that we can actually frame this to incorporate the services as well. It's something that I'm still working on, but it's a good point.
Well, I guess that relates a bit to Wendy's question before in terms of public sector innovation, which tends to be around services.
Yes.
And I guess the third one is, so what's new? Because I guess we know that each of these companies use scientific processes. We know that they're obviously pursuing new knowledge goals. We know they use different models of investigation, whether it's inductive, deductive, and hopefully abductive. So what's new?
Well, I think we were looking at the successful companies, but then in the process of looking for successful companies, we came across failures, lots of failures, and failures at the systemic level, particular examples of failures, and so on. And I think that when you look at the failures, and then when you look at the success, it's so easy. Not easy, but straightforward to say there's something going on here with this knowledge production that these companies aren't doing. And again, when you look at how many successful innovative companies are there or successful products and services, just 10%, 5%, 15%, there's a problem there. So I guess that framing the problem in terms of, we need to add rigor to create that knowledge that works as a support is a novel approach. If you go to HBR, they talk a lot about you need to have a strategy. No, you need to have a culture. No, you need to have the structure. As the latest book of Sophie Bacall, which is a physicist, tells us that there's a difference in the structure. The structure, but in the supporting that is actually a knowledge to make decisions of where you're going. If you need to build a strategy, you need to a body of knowledge on the past, but you learn where your innovation function is going. So I guess that overarching idea is the novelty kick here. Maybe I'm wrong.
Maybe it's about the boundaries of experimentation and how that's carried out in each of those different areas, and really maybe about small failures rather than big failures. How do they test the market? How do they actually try different things without investing the whole company? So there may well be some corporate entrepreneurship, corporate experimentation in terms of their successes. I actually think it's below the surface. I think innovation in science is a lovely catch fry, and I guess we all understand the importance of science, but it's often how it's employed. And I think that's when you're talking about successes and failures in companies. So I'd really look at how they do things. Yep. And the project management processes, but really drill down a little. But
yeah, that's
very
good.
Nice. I like the way you put it together into a framework. Thank you.
Thanks.
Great. If I see this correctly, we exhausted a very intensive conversation. So it's wonderful to see that despite the constraints, we had a really fruitful, proactive, and hopefully valuable conversation for the audience, but also particularly for you, Edgar. I think we all learned a lot from here. Judy, going back to your last point, I mean, personally, and being involved in this, for us, it's also a bit the consciousness. So it's not that we see success and failure of innovation, but there's conscious success and conscious failure. I'll give you an example. The insurance company NRMA told us they conduct innovation, they follow typical textbook innovation methods, But when they
That was the
succeed or
problem.
when they, well, no, but when they succeed or fail, they were not able to explain success or failure. And of course, in the
How did they
pragmatic
measure success and failure? What success and what failure?
so success for them was just uptake, a new insurance product where they gain market share.
A
Customers
successful
buying
one
a product.
they've launched. Okay.
So in the commercial world, for them, it was just innovation was defined as a product that gains in market share, and of course, failure is the opposite. And for them, you could say, well,
it was a product or service that delivered new value to the customers. That
yes.
I think you really need to look at the value notion. Yeah,
you know that's not their challenge. So they understand innovation and they define value. They just were not able, like a scientist. When a scientist has an experiment, they are pressured to explain. Now they run innovation. They're just not able to explain success or failure. Now you can argue a lot of innovation projects. That doesn't matter when you've got 10 projects innovating a product or a service, and one subsidizes the other 9. That is commercially sufficient. That's for a scientist not sufficient. And this is where I think innovation science substantially goes.
Sufficient as well. It's just not
Yeah,
sufficient.
that's well, if it's economically sufficient, if one product subsidizes the other 9, you might argue the portfolio itself has a return on innovation and I can move on.
Well, I would argue it's how they actually run those experiments that makes the difference. What are they risking? How do they test those ideas in the marketplace? Rather, I mean, that's the whole. It's really, I mean, innovation seems to be, there's a two-way process. It's not just about delivering a new product, as you say, and as NRMA found out, you know, some success, but really, so what's that process? What were they hoping for? What were their success metrics up front? I mean, it's a whole, when you look at smart companies, and of course, there are different models in different areas, whether it's, you know, Google having beta testing the whole time and just risking a small thing, or even companies trying small things. It's really how they run out that process. And
so,
obviously,
no, that's not a big question. Like even A/B testing, I talked to an organization that said yellow works better than red. We just don't know why.
It doesn't matter why, it works.
No. So yeah, but that's the difference between innovation and innovation science. That for innovation scientists, it matters why, while for innovation professional, maybe not. And that's exactly the difference between, well, this comparison, a product page or NRMA and what we propose here. And that's what I mean with conscious science. Like a scientist, when you present your PhD, you can't just present data, you have to explain the data. And what we ask for, we ask for innovation is, and that I think is the key point here, this consciousness. And that's sort of the added value, whether it's success or failure. Hey, this has been a wonderful conversation, and it's good to see how we all come together. So we will keep up the energy, as I said, whether it's BAU or LRU. It's wonderful to have you all here. Thank you so much again, Edgar. Fingers crossed for some tentatively positive interest from Boston. But again, from my side, you please all look out. And please contact Edgar for the paper, the slides, or any further conversations. And very soon, we have our series of events, and many of you here in the audience have committed to be on stage, so I can see Irvin, Fahami, and others. So we look forward to those presentations as well. Thanks for organizing, Anissa and Gemma, and we all see you very soon. Take good care.
Thank you all.
Thanks, Edgar.
Thank you.
Nice work, mate.
Thank you, Judy.